Okay, hello everyone. The indicators on my screen say that we are live and on the air, and greetings from Huntsville, Alabama, home of the Marshall Space Flight Center and the Army Missile Defense Command. I'm Vince Huegele. Today we're going to talk about teaching model rocketry. If you've seen in my bio, I've been flying rockets for about 50 years. Had rockets on my TV while I was watching the moon landing. And that interest in rocketry, always fun and always entertaining and educational, led me to get a degree in physics and then a master's in engineering. And I ended up working at the Marshall Space Flight Center for 35 years as an aeronautical engineer. I retired about 5 years ago, but I'm still doing rockets. I'm still active in the NAR. I am the NAR education chairman and have had a lot of fun talking to teachers and working with students over the years, really about 25 now that I've been doing these kind of rocket talks and training teachers and students about model rocketry. What we're going to talk about today is how to do a model rocket talk to a class of students who are being introduced to the hobby for the first time. So what I'll cover is all very basic, very general about how the hobby works, and hopefully it'll be something that will excite the children and want them to join um, the hobby, as also maybe have a science project. I get inquiries all the time. In fact, just yesterday, this really happened. It was yesterday. Got a note in our Huntsville Area Rocketry Association website for a request for a speaker. A librarian in a small town about an hour away is putting together a summer program for their library, and they wanted to do this year's theme on space and wanted to know if we could send a speaker. And we get those kind of requests all the time. Various members from our club will support that. But I also get inquiries through the education at nar.org mailbox that someone will say, "Hey, I'm got this call. I've been invited to do a talk. What do I say?" Well, if you've done rockets at all, if you've ever built a rocket and flown one, you know enough to talk to someone else about how rockets fly and what you do with rocketry. So you don't really have to study and research a lot. You already know rocketry. But what I'm going to do today is show you how to organize your material so you can present it to whatever school group that you're going to speak to. And the way to do it is I'll just do the talk and I will insert comments along the way, but it'll show you kind of what you need to have with you and what to do. We have a lot of resources on the NAR website for doing education. We have a whole blown curriculum for teachers to follow, but we really don't have this how to do a rocket talk in a video, but now we will, because this will be immortalized on the internet forever, and hopefully be a good resource for members who are wanting to give a talk. So you're invited to speak to a school or maybe a community group. This will be information you can present either as a standalone talk, as an introduction to model rocketry, or what has often been the case with many of that we will have the talk, then we will have a build session, and then maybe that afternoon we will go out and fly the rockets. So I've done that with teacher workshops where we've had to overview the material, get the rockets out and build them in the morning, fly them in the afternoon for one in-service day. Or you could do this as a part of several sessions at your school where you do the talk. The next day you come back and do a build session. The next day maybe you fly or continue to building. So it depends on what your audience. Really, you want to just explain what rocketry is. You want to do it on the level for whatever grade level is appropriate. You may be doing it to students. You may be doing it to older students who may be more interested in forming a TARC team. You may be doing this as a pitch to kind of get TARC going in a school. Or it may be something you're giving to teachers to help them how to use rocketry in their classroom. Or you may be talking to administrators or landowners or lawmakers trying to convince them that rocketry is not dangerous and you want to be able to use a public field or a private field. So if you have a school period, that might be about like 30 minutes or 40 minutes. You can tailor your detail that you go into depending on the age of your students, and then also how much time you have. But you'll be able to explain really what rockets are and how they will know more about them. So you'll talk about rockets in general, the model rockets, how they fly, the engines that go in them. That's kind of a big category. How they are launched. I'll show some pads with a firing system. We'll talk about rocket flight, aerodynamics, stability, also a lot of safety, and then wrap up with what the NAR is. And if you're coming from a local club, what services your club can offer to help students fly with you and either do their science assignments or just have fun flying. So what you can start off with, and again, this will be the talk that I give when I go out. So you may start off and say, okay, what are the different kinds of rockets that you know about? There are the NASA rockets that fly in space. Those are the ones that we see getting launched down in Florida, and they carry things into orbit and into high orbit for space station. You have so they have the space rockets that not just NASA, but other developers are launching now too. There are military rockets that are used as weapons fired from one enemy to another. Those are typical type rockets. You also have a sounding rocket that might be used to go up and down to measure the atmosphere or take pictures of comets or do some kind of astronomy. But what we are going to talk about today are the model rockets. These are rockets that individuals can build, students can build them, teachers. I started building them, and I still do. They're fun to fly. This is what we're going to talk about today. And then you may ask, okay, so who has ever seen a model rocket launched? And you look for a show of hands, and they get invited and kind of draw into your talk. And so, okay, who's seen a rocket fly? Who's ever built a rocket? And you look for a show of hands. And who's ever launched a rocket? And then you look for a show of hands. And you say, okay, so we're going to talk about rockets. There's a lot of different, even though all the model rockets fly in a similar manner, there's a lot of different kinds of rockets, and you'll talk about the different types. And this will be whatever, depending on your rocket collection that you have brought. You'll need a big box to bring all of your rocket stuff with, which we will probably keep and hold in place for whenever you go do a rocket talk. You'll take the same box of rockets out. So that there are sport models. There are rockets that you fly for fun, that you just go out and you enjoy them like a model airplane or a model ship. You can fly rockets. We also like to make scale models with rockets. This is a military style rocket that is fun to fly, but it actually is a miniature version of an actual rocket. That's why it's called scale rockets. So scale rockets of military. You can also have scale rockets of the NASA type rockets. These are some of my favorite types, but this is one that flies on about a B or a C motor, and it's a miniature version of a rocket that NASA had called the Ares 1. A lot of the models that you will fly will be historic representations of models from like the Saturn V that went to the moon, or the Mercury Redstone, and you can learn a lot about rocket history by building these scale models of NASA. You can also use your imagination in model rocketry to build science fiction versions of models. Not just, this was a kit bash that I made that was something fun to do, futuristic jetliner look, but you can also have miniature versions of Star Wars, Star Trek, Battlestar Galactica. All these different science fiction themes can be used for rockets, and it's a lot of fun. This is called the Protostar, sort of a retro 50s model that I kind of like building. So you can build models like this. You can also have rockets that are staged, that are two-stage rockets that have two motors in them. The bottom part fires, and then it falls off, and the top stage lights, and it continues on to a much higher altitude. Staging is very common in the professional rockets. You see them with the NASA flights that have the boosters that drop off. So this can also be done in model rocketry. And I have in the back a three-stage Farside rocket, which I recently finished but haven't flown because I still have all the stages. You don't have to say all these things, but you think them. You can also have rocket gliders that will launch like a rocket and then come down like a glider. Those are fun to build, and you might see those out at a flying field. You can have odd-sized rockets that look like saucers that take off straight and come back down. And those are fun too. They don't go very high, but they work really well in a small field. Now, the NASA rockets don't just fly for fun. They are designed to carry something up into orbit, to launch something into deep space, like the recent James Webb Telescope that was just flown. So in model rocketry, you can have payload rockets as well. This has a large upper section, and the nose cone comes off, and you can put your payload, is what we call whatever you're launching, into the top of the rocket. This could be a science experiment, could be a camera, an altimeter, all sorts of different devices that you can fly. This particular rocket is designed to carry a raw chicken egg. Now, why would I want to do that? Well, we'll get to that in a little while. But a lot of the model rockets can be used to launch payloads. So those are the types of rockets. Then I would go in, and whatever your collection is, you can show more or less of it. There's also high power rockets. And this might be too big to carry into the school, but since it's here in my office, I can show you that there are big rockets for the adults. And these are fun too. They fly the same way. They have larger motors, but you can get into bigger rockets, and even bigger than that you couldn't carry into a school, but you could show pictures of them and how they fly. Then I would talk about the parts of a rocket, how you have, you can hold one up, and you might want to use something the size of a big Bertha for your demonstration, because you can wave this around and it can be seen pretty much by anyone in the classroom. And it's also, easy to see. So your average rocket is going to be a paper tube. It's going to have balsa wood fins, or they might be plastic fins. The nose cone, that's the front of the rocket, will be also likely plastic or balsa wood. You also have on the rocket a launch lug, which we'll talk about later, and you'll have a place in the back for the engine mount. This is going to hold the rocket engine, which has all of the rocket fuel in it, which is what burns and propels the rocket. We'll talk about that more in a minute. So you have inside the rocket a parachute that will come out, and the rocket flight profile. And here you could show a video, but I'll just walk you through it. You have the rocket sitting on the pad. You give the countdown. You press the firing button. Rocket takes off. It flies. It's moving along as long as the fuel is burning. The fuel burns out. But the rocket doesn't just stop. It's got a lot of energy with it, so it's continuing to coast on up to its peak altitude, which we call the apogee, and then it will blow out a parachute and come down gently and safely. Now, if you didn't have anything happen to put out the parachute, the rocket would not come down slowly. It would come down just as fast as it went up, and you don't want that because that would crash the rocket and might hurt someone or damage property. So you always want to have a recovery device in your model rocket so that you can get your rocket back and fly it again, because that's what rockets are. They're reloadable. So it takes off and goes up and would come down, and this is the same way it went up if it didn't have a recovery device. And it could be a parachute or it could be a streamer. Now, to further illustrate the parts of a rocket, here is something very cool that I would recommend that if you're going to do a lot of talks, put something like this together. This is a piece of PVC tube that's clear, that happens to be the same size as a Big Bertha nose cone. And whatever nose cone you can make that fits, that's good. I had one of our members make this and give it to me, so you can see how the inside of the rocket looks. And this really is the one picture worth 1,000 words of explaining how a rocket is put together. I have wooden fins here. The balsa fins go through to also create the engine mount, and I have a expended engine in here to show how it fits. So this is something that you can use to explain the parts of the rocket with a parachute, how it's connected together. And you can also see the wadding inside that I have as dog barf that also illustrates how each rocket is put together, and the launch lug as well. This is something you can then pass around to the crowd while you're talking with the rest of your presentation, and they can all take a look at it, because it's pretty well self-explanatory on how the rocket is made up. So wooden fins, plastic nose cone, and most of these rockets can easily be assembled. You can make that point that this is not hard to put together a rocket like this, particularly if you already have a fin can assembled. That's easy to build, and the parts are pretty much straightforward. You can put together one of these rockets in the course of an evening, or at most a weekend on your kitchen table with white glue, some masking tape, ruler, maybe scissors. They're very easy to do. They come with great instructions on how to build them and fly them. So it's really not rocket science to have to know how to build a rocket, but you do have to follow the directions. And these are the pieces that come with it. So what then I would do is you move from the parts of the rocket to talking about the motor. The motor is the key part of the model rocket. This is what fits into the bottom. This is where the rocket fuel is. You tell them this is, and this is in a suspended case, but you say this is what powers the rocket, and this is the real rocket science. It's all the hardest part of rockets is in the engine, and that's done for you. So all you have to do is do the craftsmanship on the airframe. The motor, the hard part, is made commercially, and that's what you want to use to buy to fly your rocket. Your motor goes in the bottom. It's loaded in. It's retained. You launch the rocket. Parachute comes out. You get it back. Then you take out the old casing. This is the expendable part. That goes in the recycle bin. It's just a cardboard tube. Throw it away. Get a new one. Load it back up. You're ready to fly again. So all of this part of the rocket comes back. You get to fly it over and over, and that's the fun part. You have to buy an engine each time you fire the rocket. So those come in multiple packs, or you can buy them individually for the larger motors. So every flight requires a motor. The size of the rocket, the motors are indicated by a nomenclature on the side of the motor. There is a number, and this is a B66. The main thing for beginners you want to know is what is the letter code on it. This is a B motor. It is indicated by the letter of the alphabet. Rocket motors will go from 1/2 A, B, C, on up to higher orders of the alphabet. And each time you go up a letter in the code, you go up to basically twice the power of the motor. So motors come in different sizes. They come in different power levels that will take your rocket to different altitudes. This would be a standard size motor. You can show that and pass them around. If this was a C motor, it would be totally full of propellant. A B motor would be about half of it. An A motor, half of that, so that each successive letter is twice the power of the lower grade. So you could get an ABC motor in this size casing. The next size casing would be a D motor, which you could see is bigger. You can show how these are larger. Then you can jump up to an F motor, which is bigger. And I could say at this time that if you had the size of the motor, will depict how high the rocket goes. That's always your question. How high is my rocket going to go? Well, it depends on what size motor you put in it. And you can directly proportion the altitude of a model like this with a motor and explain, okay, if I put an A motor in here, an A motor will send this size rocket 100 feet. A B size motor will send this size rocket 200 feet. A C size motor will carry this rocket 400 feet. A D size motor would take this rocket 800 feet, and the progression goes on. And then I say, you don't want to put a D motor in this rocket at 800 feet because you won't see it again. And I make the point that you don't want to send your rocket out of sight. That sounds like a cool thing to do, but you've got to see where it goes so that you can see where it lands so you can get it back and fly it again, and you don't want to lose your rocket. So don't just want to send your rocket as high as possible. You want to use the right size motor to make it come down within the flying field that you're in. And there's a lot of adults that don't seem to understand that in high power, but that's another story. So you can further make the progression that have two F motors here. This is a black powder F motor. This is an Aerotech motor that uses a different kind of fuel, and the difference fuel. This is an ammonium perchlorate rocket fuel, and it is the same type rocket fuel used in the shuttle boosters. And that's really cool to think that your rocket motor and your rocket are flying the same way that the NASA boosters are. And that's really fair to say, because one of the whole points of model rocketry is that it's just a miniature version of what NASA and the military do. The rockets fly with the same principles, and even with the same propellant, they're just smaller versions. And if you as a student can understand how these smaller rockets work, you can understand how the larger rockets work. They use the same vocabulary almost, the same principles of flight that make this rocket stable will make the large rocket stable. And to further underscore how big motors get, because everybody will, what's the biggest motor you got? Well, this is a J motor, and it's easier to bring a casing in with your rocket box than the rocket that this flies in, because this flies in a 4-inch diameter. This is about 6 feet long, and that would be fun to show. But then you have to say these motors are for adults. You got to be over 18 to get them, and also to be certified, you have to have a rocket license to buy these motors and use them, because they're bigger and more powerful and have to be more careful with them. But you can go to the store in Walmart and buy these size motors for your rockets. And that's the difference. So then you could say, okay, a J motor, how many A motors is worth a J motor? And you could do that up on the whiteboard if you wanted to go that far. So how do you fire these motors off? So then you will talk about igniters, launch pads, and firing systems. Inside, as the motor is put in the rocket, how do you fire it? How does that make it go? Well, you have something called the igniter, and you could show one, and it goes up inside the bottom of the rocket, and it is an electrical device that will flash a bit of fire and smoke inside the motor to start it off. But it's electrically operated, just like the NASA rockets are. And you fire your rocket not by lighting a fuse, but by pushing a button. So you'll have the rocket on the pad, and then you can bring out a launch pad and show them that when you're flying a rocket, you can't just set it out on the ground somewhere and light it off. You have to have a launcher. And this, of course, is a commercial launcher from Estes. You could show any other kind of launcher or something that whatever you can bring in is. So the launcher will have a base. It will have a blast deflector to protect the ground from the fire that comes out of the rocket, and also to protect the launcher from the fire and the blast. The rocket is attached to the launcher by a launch lug. And this is like a little straw that fits on the rocket. And you will have showed this when you showed your general parts of the rocket, how that works. And it holds the rocket on the pad while the ignition is starting, while the motor is coming up to speed, and while the rocket is sitting there. Because for the fins to work, to guide the rocket, they have to have air flowing over them. And for the fins to work, the rocket has to be moving at a certain speed. So you have this launch rod that holds the rocket, and the rocket rides up the rail until it is going fast enough for its fins to work to guide it to be stably, have a stable flight. All rockets have to have a launcher. The bigger rockets have a bigger launcher, but every rocket has to have a launcher to hold it so that it's in place and aimed at the sky, and will have enough guidance on the launcher to get up to speed. And I'll talk about stability here in a minute. But you show the launcher, and you can have a rocket on it, and that's part of something that you have to have to fly. Then I will typically bring out the firing system. And I'll back up a little bit here. This is a personal system that I have. Here's the lead wires and the clips that go to the bottom of the rocket. And what you'll do, doing the talk, is you'll pull all this out and show it at full length, how it all fits together, and that you have a battery that fires the rocket. In my case, this is the gel cell that I use for many demonstrations. You can show whatever launcher you have or firing system, and that how this works electrically, that you have a control that will work to fire the rocket when you push the button. But you have to have the battery hooked up, you have to have the rocket hooked up, and you have to have a safety key of some kind to disconnect the power to make sure that the rocket's not going to go off when the button may accidentally get pushed. You don't want to have any kind of accidents during your flight. So when the key is inserted and everything hooks up, you will have a light, and that actually comes on, and that means that there is power going through your firing system to your igniter, and that you will have, you're ready to fly, and that your system also is armed when you push the button at the end of the countdown. Now, this is important to have this kind of firing system for safety. The rocket will not fire until you push the button. So if you are all set up, you're out there on the field, and some dog walks up to the launcher, and somebody's little brother goes chasing the dog, you can hold the launch. The rocket's not going to fire. Everything's okay until you get everybody far enough away from the rocket for it to fly. So you get the dog away from the rocket, you get ready to fly, and as an airplane flies over or a helicopter or something, hold the launch. You're not going to fire it until you push the button. So when everything is clear, you do the countdown, you push the button, the igniter fires, and the motor starts, and the rocket takes off. And what you can do in your presentation is actually take an igniter and hook it up like this and do a demonstration of firing it. I just got an old one right here, and I don't want to fire an igniter here in my office and smell it up. So we won't do that. But whatever your firing system is, you bring that out to explain that the rockets have to have a firing system to launch it. Being that it's controlled with electronics, you don't have the uncertainty of a fuse like fireworks, and you have control over when it fires, and to make sure it's all safe. So this is my system here, and it always is a lot of fun in the school to have a big flash when your igniter goes off. They'll remember that. But it also underscores the safety and control that that you have with the rockets. So I showed that you had to have the rocket on the pad to launch it until the fins can make it fly. The fins, and this is where you talk about aerodynamics and stability and flight. The fins are on the rocket, they're on the tail of the rocket. They have to be put on the tail for the aerodynamics to work. When the rocket is being thrusted in this direction, its reaction is to go in the other direction, and it will fly. But it has to have fins on it to make it fly, to keep it going straight because of the aerodynamic forces that are on it. Every rocket has a balance point. This is called the center of gravity. There is also a value that we call the center of pressure, which is going to be located behind the center of gravity, which you need to have to make the rocket fly straight. If you don't have these relations properly, the rocket will spin around and it will crash, and you don't want that to happen. To illustrate that better, I bring out an arrow, which is, and this, I don't know where this came from, it's kind of broken, but makes the point, and it's easy to bring into the school, that how many of you done archery? Okay, nobody. Okay, maybe a 4-H group will have done that. But how does an arrow fly? Well, I don't know. You know, you bring it in, come on, didn't you see Avengers and that guy with, you know, stuff? You shoot the arrow goes straight. Well, the arrow is not just a tube. The arrow is balanced just right so that it will fly when it's shot. And if it's not balanced, it won't fly. So what you have, if you notice on most arrows, there is a bit of a tip that's adding weight to the nose of the arrow. And at the back of the arrow, there are these little feathers which act as fins. So you see a similarity here of how this works. And this is exactly the way an arrow flies, the same way that a rocket flies, that you have a bit of it nose heavy and tail fat is how I explain it. And that makes the rocket or the arrow balanced right. So in the same way, maybe you've seen a weather vane that's on the top of a barn. And how does that work? Well, the air flows against the weather vane, and it puts more pressure on the tail than it does on the nose. So it pushes the tail around to point it in the direction that the air is flowing, because there's more pressure on the back than there is on the front. And that's the same way a rocket flies, is the air flowing over it has more pressure on the tail, which keeps the tail in the back and the nose in the front, and the rocket going straight the way you want it to. So that's a little bit about stability. I mentioned the recovery systems, that a parachute will come out of a rocket, and in this case, I have a streamer that will come out. You need to break up the aerodynamics. All of the stability, which I just showed and talked about, is for keeping a rocket going straight when it is being powered. Built into the engine part, and I forgot to mention this, but in each motor, there is the rocket fuel, there is something called a delay train, and then there is an ejection charge. So in every rocket motor that fits in, the fuel will fire, the rocket will be allowed to coast up to its peak altitude, and then there will be an ejection charge that fires. Now, you should be telling this back in the engine part, that blows out the nose cone, and it will either be a streamer or a parachute or some kind of recovery device that will change the aerodynamics of its ascent profile so that it will come down slowly and land, and you can recover it. So parachutes are great. They have to be folded up, and they're fun to see and chase after. A streamer will bring a smaller rocket down a little faster, like this, because it's a smaller rocket. The streamer slows it down enough where it will land without breaking. A larger rocket is going to need a parachute to bring it down so that it will not break when it lands, and you won't pop the fins off. But you have to be careful that you don't fly too big a parachute when it's really windy, or the rocket will drift away and you will have a long walk or run to try to find it to get it back. Streamers come down a little faster and closer to the launch pad. So if you are doing a build session and flying small rockets in small fields, streamers are easier to recover. They come down closer to the pad in a smaller field They are also easier and quicker to build. To fold up a parachute and learn how to put that in a building a rocket will add 15 minutes or so, or 5 minutes or so to your launch or your building time. Streamers are a lot quicker to build if you're needing to keep up with time. So then I talked about the aerodynamics, and I talk about safety, that rockets are safe because there is a safety code for you to follow. These are rules that have been developed over 60 years. They work. They make your rockets fly well. You follow the directions. You don't get hurt. Your rockets don't get lost, and everything is good. The rocket code, safety code, has been developed by the National Association of Rocketry. They are the same people who certify these motors to make sure that they are quality products. And depending on your audience, I don't know if wherever you are may or may not have fireworks for sale. And you can use your own discretion about talking about this, but I'll briefly say the difference between a model rocket and a firework. Okay, they look about the same. They seem like they're about the same. What are the differences? And this isn't a burned out firework that I got here a long time ago, which I used for my talk. They look about the same, but what's the difference? Well, fireworks will have fuses. You light the fuse, what's it going to do? It might blow up, it might do nothing, it might fly the way it's supposed to. You don't know. Model rocket motors are made with high precision. They're very reliable. They're a good quality product. They're going to do what they say they're going to do, and they're going to launch your rocket and make it fly. It's going to work. The fireworks, you never know. You know, if this is supposed to go up and shoot out a flaming ball, then maybe it'll do it, maybe it won't. Not very reliable. Model rockets are reusable. You build them. This thing is one shot. You don't know what it's going to do. It's a whole different thing. You know, fireworks are for doing fireworks shows and whatever. Model rocketry is a safe hobby that you've got different intentions and different results. And a lot of people get hurt with fireworks. You don't get hurt with model rockets because you are staying away from the launch pad when you're firing them. You're out in a big open field. You're paying attention to what you're doing. You're following the code, and all that works out really well. So what else can NAR do for you? Besides generating the safety code and the safe practices that have worked for millions of flights over these 60 years. Well, we are not, and you talk about yourself, maybe you're representing a club or maybe you're there on an own, and you may not be an NAR member, but you are representing model rocketry. But the organization is worthwhile to mention, particularly if you are a club. Clubs are fun. You get together of like interest groups of people, and you work together and enjoy one another's company, learn from each other, see what other people are doing. It's a lot of fun. So you want to go to Rocket Club launches and see what's going on, and NAR does this kind of thing. We don't sell rockets. We certify the motors, we certify flyers, but we are the rocket people. We're not the rocket salesmen. We are the ones who you call when you want to hear about rockets, just like this talk. And we want to help you, whether you're an adult or a student, whoever you are, wanting to learn about rockets and fly them and have fun and do them safely, do them with us, do them with the organized modelers. NAR does a lot of events. We have, you know, the sport launches. We have competition launches. We also have a lot of student launches that are specifically geared toward educational effects. And here's where you can talk about TARC. You can mention that well, it used to be called Team America Rocketry Challenge. Now it's the American Rocketry Challenge, I think. But this may be what they're mainly wanting to hear about, and you can talk more detailed about whatever you're needing to do. But you can explain that students will build a rocket as a team. The rocket's intent is to carry a raw chicken egg in the capsule. It is to a specific altitude, which may be something like 800 feet, and a specific duration that may be like 45 seconds. And you score the flight, and the best flights will win. You go through a qualification process. If you launch your rockets and they do really well, you will be invited to fly at the Nationals, where the top 100 teams go to Manassas, Virginia, and compete for some big money. The winners there are national champions and will go on to Europe and compete against other countries for the international title. And that's really fun. And that's where you're winning the money. So your rocket in a TARC model will be something like this, something big enough to hold a raw chicken egg and keep it padded. You'll also have an altimeter in there that's an electronic device that senses the change in altitude due to the change in pressure, so it knows how high your rocket went. And then you're going to have to fly it on an E or an F size motor, because it's going to be kind of heavy and you're trying to get up to 800 feet or so. And all the challenges that come with this to make this kind of rocket fly. You can say the registration starts in the fall, and you have until the 1st of April to make your flight, and then the nationals are in May. So you can talk about TARC. You can leave some literature about it. That's always something good to do. And by the way, all of this stuff that I've shown you, if you can be used if you're doing a display or an exhibit, if you have some booth at some community event, science day at a school, and your club can come out, or you're invited to come out. You can have all these rockets laying out and show them the differences in the engines and the different size rockets, and can have some kind of brochure holder set up to put out your literature. We have a lot of brochures that are downloadable from the NAR website, but also you can make up your own that will indicate your launch schedule, your contact information, some little card to hang out. You can do it with a barcode if you want to. And when we do these exhibits, it's good to have a clipboard and try to get people to write down their name and their email so that you can contact with them and say, hey, our next launch is coming up. We're glad to meet you at the Science Day. Do you want to come and come fly with us? So that's how you talk about TARC, and you can conclude with how doing rockets can help you make better grades. You can do science projects with them and learn a lot, and it makes your lessons a lot more relevant. Teachers are looking for ways to teach STEM that will not just be material that children try to memorize. Model rocketry will teach you how to solve problems that will apply all the different science topics that you're trying to convey. And a list of those would be, and I would bring this out if I was talking to the teachers, I'd say, obviously, you can talk about physics, Newton's laws, velocity and energy. You can also have math applications for trigonometry if you want to go back and do the old-fashioned triangle. That's the only way I remember sines and cosines, is I think of a rocket going up and the angle that's formed with it, and then I can remember how sines work. And that's all the way back to whatever was 10th grade algebra. You can talk about chemistry, how combustion works in the motor to propel it, material properties of strength to weight ratios, heaviness of materials, glue properties, what makes a better adhesive in holding your rocket together. You can talk about the aerodynamics of drag and stability, but you can also talk about electronics. The very first electrical circuit I ever learned, and it may still be the only one I know, is the firing circuit from battery, switch, igniter, which is a little bit of electrical resistance, and therefore you've introduced them to electronics. You talk about the craftsmanship of assembly skills, weather prediction. If you're going to launch the next day, you will never watch the Weather Channel as closely as you will trying to get a forecast for your launch. You can talk about space history with rockets and use the models to teach those, and safety practices, and then something that is really more of a college level, professional level workforce development is the idea of systems integration, where you have all these technical disciplines that I mentioned, the chemistry, the math, the computer design, which you can also, we've got great programs out there for designing rockets on the computer. There's great things, so many fun things you can do with rockets without even building them that will appeal to the students. And you can that way also embellish their skills with computing things about, well, why does my program say this? Where's the equations coming from? Well, they won't ask that, but you can say, oh, well, there's equations here, and you can figure this out yourself. So there's all that it teaches. And in teaching teachers, I thought I had to give them lesson plans. We have on the website a lot of curriculum and things that teachers can immediately take and use. But I also found out when I was doing a museum of flight workshop in Seattle, those teachers just wanted to know the rocketry technology. How do you pack a parachute? How do you put the igniter in and hook it up? And, oh, well, I know that. I was trying to come up with the pedagogy of science as inquiry and, evidence and measurement things and all these teacher terms. And they said, no, we'll take care of that. Tell us how to do the rockets. So since then, I've focused mainly on the technology. And that's what you can do too. But teachers really want to know these kind of things. They're desperate for teaching tools for STEM these days, and it's really important. Rocketry teaches students how to think, and so much of what's going on in schools is trying to teach students what to think. Trying to load them up with, some kind of agenda. But it's better to teach them to think themselves, solve problems. How do I make my rocket go higher? What's making it not work? You think through these things. The learning process can be applied to anything else, from fixing your car to why does my dishwasher not run? All of this critical thinking and analysis that you can learn through rocketry. And it really makes the science lessons much more relevant. So I'm needing to take some time, I think, for questions. All of this will be stored and you'll be able to view it again later. Last thing is that when you leave, have contact information with your presentation so your teachers can get back to you, because they probably will call you in the spring and say, oh, we have some extra days that we need to have for enrichment. Can you come do a launch for us? And that's a whole nother presentation. So let me see what your questions are. Okay. Lee Olenek, hello, haven't seen you in decades. Yes, you pass around anything you can in classes. Usually something that's a very sturdy rocket that the casings are fun. You can pass those around, but anything that you're holding up, yes, pass those around. Bring those for show and tell. this diameter, where'd it go? This rocket, this is, I guess, a BT-60 size, if this is a Big Bertha nose cone. So that's a pretty good size. And I can't tell you where to get a clear tube from. That'll be an exercise to the student, but you don't have to do this size. You could do something larger or smaller. There's the old fashioned Estes Phantom that was a BT-20. That would still work. I've got one of those somewhere, but I had more fun with this. So yes, the motors. Yes, in a typical presentation, I would have charts going with all of this, and I would be saying the same thing that's on the charts in my presentation. There is some of that material on the NAR website at Education Resources, but I'm going to, because I've been working on this and trying to address how to give a rocketry talk, I will have some more slides up on that. But yeah, if you've got some text and pictures and video, those are good too to put in. I've didn't do that this time for simplicity, so I didn't know how to toggle back and forth between my word charts and waving my hands with holding a rocket up. So those are good things to do too. It's up to you. If you have, we will have presentations that you can just wholesale borrow off the NAR website and just use them. That's why we have them there. That's what they're for. But you can use your own and tailor them to your particular launch area, pictures of your members, pictures of your schools or your TARP teams, or however. So we're doing that, and we're trying to obviously address the remote learning capabilities and requirements that are needed to have presentations like this so that anybody anywhere can see them, and you don't have to get called up to go do a presentation. I guess I'm pretty much 2 years ago talking about going in and doing a talk where you don't even, some schools don't even have schools. So how would you do that? Well, you do the same thing we just did here. You just do it talking to your screen instead of a large student. And we've had to do that already in the last 2 years. We've had several presentations. That's exactly what we've done, and it's pretty awkward, but I think I'm getting really out of time. So appreciate everyone's attention. You can contact me at education@nar.org for comments or other questions. We'll try to have all of this on the website. And of course, on this event thing, it'll be repeated for 30 days. Okay, so I think I'm about out of time. It's time for a lunch break. Appreciate everyone's comments and attention. And aim high and have fun and stay in touch. So I will now pull the plug.